So you see, my friends, the problem is not easy problem. And I told you, even the people who are expert in this field will have, um, it is not easy for them to handle that. So please, absolutely do not beat up yourself. If you have problem to understand that, no problem. Just stop the video here and go and listen and check the video another time, another time, and feel free to ask if you have any question, because I'm telling you this problem is some sort of confusing. So absolutely do not take it personal. Okay, and the reason I chose this problem is that I just wanted to impress you that what great things you can do with R. Okay, so now you know about the problem, that a bucket and balls and taking all those things, and you want to see all the numbers with the sample that you get. And here it says if n is smaller than 10, the probability is 0, because when you take 9, of course you cannot have 10 numbers. And more balls you get out of the bucket with replacement, it increases the chance of success. Okay, so the result would be a curve like this. Okay, as far as time allows us today, we are going to try to catch this goal. And as I mentioned, please, as soon as you notice you can do something yourself, do it on your own. Otherwise, just follow me and do whatever I do. Okay, you see here it says if the sample size is smaller than 10, the probability is 0, as you can see here. And when the sample size even is 10, the probability is very small. You agree with me that you have 10 balls in a bucket and you want to take 10 balls out of the bucket with replacement, and there is a very small chance that you get all the numbers from all the balls from number 1 to 10. But when you increase the number of samples, the number of balls that you take out of the bucket, the probability increases, and while you get 60, it gets close to 100%. And also see how much the results can help you when you want to decide what should be the sample size. For example, somebody tells you, if I want 50% chance of success, what should be the sample size be? You got here and you say that the sample size would be something like 27. See how much it gives you the power for doing the analysis. But in the old days, only people who were expert in the field of mathematics, probability, statistics could do these things. But these days, with computer, programmers can do anything they like, because computer have huge computational power that it can calculate anything. And today I'm gonna show you, my friends. Remember, we are gonna talk about all these things in depth when you get courses like Informatic 455. So that's the reason I'm saying that just take it easy, my friend. Just make sure you can follow what I'm talking about. That thing. No expectation of innovation from you at this phase, just understanding and get the impression of the fact that how much R could be helpful with our data analytics project. Now we are in our studio environment and we want to do the code. You can start it any way you like, my friend, but let's start with sampling part. With the sampling part, in which we do the experiment that is taking the balls from the bucket. There are 10 over there, and if you have forgotten the details about the sampling, please stop the video here, go and check the video we made last week. And just again, I'm telling you, wherever you can do it yourself, do it yourself. It is better. So let me name it experiment. Okay, the experiment that we have is sampling. The sample, we want to sample from 1 to 10 because there are numbers 1 to 10 over there, and we go for the size. Okay, what is the sample size that you want? Let's start with sample size of, for example, 15. Okay. Another thing is replace. We have talked about all these things before, and replace is true. What about the probability? Probability of all of them are the same because in a bucket we have 10 balls, so probability of each balls get picked is 1 over 10. Since all of them are equal, we are not gonna put any probability. So I run it, and after that, when I print this, what should be the result be? It should be 15 numbers, a vector of 15 numbers. That numbers are anything between 1 and 10. As you can see here. Another thing, let's check if it is a success or failure. When it is success, when we have all the numbers from 1 to 10, is it success or failure, my friends? Check it. Stop the video and try to make it yourself. Okay, I'm gonna give the answer. It is failure because, for example, I don't see 3 here. 3 is not here, so it is failure. Let's do it another time. I'm gonna repeat it as much until we get success. No, I'm not promising because maybe it's never gets success. Okay, again, we don't have 3, so it is failure. Another time. Why it doesn't have 3? Failure. Okay, now it doesn't have 2, so it is failure again. No 3, failure. Okay, no 5. So you see, when the sample size is 15, the probability is still small. Okay, but now we are good with generating these things. But you notice that it's very difficult to check if every number is over there. Is there anything else that we can do? Yes, my friends, we can sort the vector. Let's check it. I put the name. See how much R is giving me power in analyzing a problem. That's the focus of our session today. So SEXP, that is sorted experiment, or let's make it sorted vector, and also let's make it V. It's easier. So we have SV sort. We have talked about sort last week, and I put V here. Okay, now let's do it another time and see this time how much it is easier. SV. Okay, I run it now. So you see, we have V that is generated, but here I have the sorted one. Now quickly I can say if it is a success or failure. You see 1, after that it jumps to 3, so it doesn't have 2, so it is failure. Another time, it's very good that the class is recorded, so I'm feel relaxed that you can check the video, because if it was in class, Okay, a little bit worrisome. Okay, here you see it doesn't have to. So you see, just by adding sort, how much it is helpful, my friend. Okay, so another thing that we want to do is making that check automatic, not by eyes. So how come it generates SV and after that it checks if it is a failure or if it is a success? Okay, so here again you see another run. We have the vector and here we have the sorted one. We have 1, 2, 3. We don't have 4, so it is failure. But as I mentioned, we want to make it automatic. So instead of we with human intelligence check if everything is over there, we want to do it with R. Is it possible? Yes. With the code that we have learned together. So what is the code that we can use? You can stop the video, my friend, and you think about it, how you can do that, how you can write the code that checks if this sample is success or failure. But I'm gonna write the answer here. Okay, so remember we talked about if else statement. So we are gonna use that. If else statement. Okay, so we are going to check if 1 is not in the vector. Okay, we are going to see if 1 is not in the vector. If it is not in the vector, it is failure. Let me show you these things in this way. So if it is not, failure. But if it is there, let's go and check if 2 is not over there. If 2 is not over there, it is failure. Otherwise, go and check for 3. If 3 is not over there, it is failure. Otherwise, go and 4 and like that. So I'm going to do it for the first one. You know about these things. If it is not over there, we have talked about this. You need to put this exclamation mark and 1 this in SV. So you see, my friend, here we have 1 inside SV, not 1 inside SV. So if it is not inside SV, of course it is false. Otherwise, let's go and check about 2 and like that. So stop the video and try to do it yourself. It is the completed format, and now you can use it to make your code over there. And again, as I told you, take it easy on yourself. Just try to catch up. Okay, and you see that problem that seems that much complicated, see how well we could model it with just an if-else model. If-else model, check if 1 is not in the vector, and if it is not in the vector, it is false. Otherwise, go and check 2. If it is not false, go until it gets to 10. Now you may ask, well, if we have these things, why we need to use the sorted ones? Because when R is doing it and there is no involve of our human intelligence, we can use V instead of SV, and that's correct because it's computer and it can very easily check if 1 is over there and without sorting. So now we are going to remove SV and substitute it with V to make our code even simpler. And now here see the masterpiece of our everything, this much simple, create it and check if everyone is over there. And here it checks it and tells us false.